everyone, this video is about implicit differentiation. So if we have y equals 3x squared, we know that the y prime is 6x. Or we can say the dy dx is 6x. Or we can say, the y is 3x squared. So we can say the d dx of 3x squared. Or we can say the derivative of 3x squared with respect to x is 6x. So we have this kind of notation now. We use this one, d dx 3x squared equals 6x. So using the chain rule, dz dx equals dz dy dx. So d dx of z equals d dy of z times dy dx. So this means if we have, for example, d dx of y to the power of 7, this is equal to d dy y to the power of 7 times dy dx. So the d dy of y to the power of 7 means we differentiate y to the power of 7 with respect to y, so we get 7y to the power of 6. So it's just like the usual differentiation, but instead of x we are using y here. So in implicit differentiation, when we use different letters, not x, so for example d dx of 5y to the power of 3, you see we have x and y here, or d dx 4t cubed plus 7t squared plus 10, so we have the t and x different letters. We differentiate as usual, we think of the y and the t as x, so just like the derivative of 5x cubed, which is 15x squared, but we use y here, so 15y squared. And here if we differentiate, we get 12t squared plus 14t, but we multiply by d box dx. The box here means the different letter we are using, so in this case we are using y, so 15y squared dy dx. So the derivative of 5y cubed with respect to x is 15y squared dy dx, and the derivative of 4t cubed plus 7t squared plus 10 with respect to x is 12t squared plus 14t times dt dx. We have to use parentheses here. Yeah, if you wanna expand, you can do this, 12t squared dt dx plus 14t dt dx. So for example, if we have 3x to the power of 4 plus 5y to the power of 6 equals 7, so we have this equation. If we want to do it explicitly, if we want to differentiate using the usual method, we can express everything here in terms of x, so we get y equals something in terms of x. If we move 3x to the power of 4 to the right, we have this, and then we erase both sides. We divide by 5 first here, and then both sides to the power of 1 over 6, we get this y equals something, so y is the subject. Now we can differentiate as usual because this is just something in terms of x, so we have, bring the power down, 1 over 6 times exactly the same 7 over 5 minus 3 over 5x to the power of 4. The new power is 1 over 6 minus 1, which is minus 5 over 6, times the derivative of the 7 over 5 minus 3 over 5x to the power of 4, which is minus 12 to the power of 5 times x to the power of 3. Now if you want to simplify, we have 1 over 6 and minus 12 over 5, so divide by 6, we get minus 2 over 5 x to the power of 3 times 7 over 5 minus 3 over 5 x to the power of 4 all to the power of minus 5 over 6. Or we can also write it in this form, minus 2x cubed over 5 times, you see this is minus 5 over 6. If we move it like under the division line, we get 7 over 5 minus 3 over 5x to the power of 4 to the power of 5, positive 5 over 6. Now that's how we do it explicitly. So explicitly means we start with this y equals something in terms of x. Now implicitly what we do is we differentiate both sides with respect to x or y. So here d dx of 3x to the power 4, as you can see the same letters, x also x, so we get the usual 12x to the power 3. But for this guy here, if we differentiate this with respect to x, well, we get, 6 times 5 is 30, the new power is 5, so 30y to the power 5, but we have to multiply by dy dx. On the right, the d dx of a constant is simply 0. So if you move 12x cubed to the right, we get this. Here we can simplify, divide both sides by 6, so we have 5y to the power 5, on the right minus 2x cubed. And so if you divide both sides by 5y to the power 5, we get this as the final answer. Now in case you're wondering, this is the dy dx or the y prime, and this is also the dy dx or the y prime, but they are a bit, they look different, but actually they are exactly the same, because remember y equals this. So if you replace this y with 7 over 5 minus 2 over 5x to the power 4 all to the power 1 over 6, you will get exactly the same result. They are exactly the same. Now implicit only means, this is why we have to use this implicit differentiation, because sometimes it is impossible to express the equation as y equals something in terms of x. That's just impossible. So for example here, there is no way you can differentiate this explicitly, because we cannot turn it into y equals something in terms of x and only x, so there is no y on the right side. So we cannot do it explicitly. We cannot make y equals something in terms of x only. So to find the dy dx, we differentiate both sides with respect to x. Now for x times y, this is using the product rule. The u is the x, the v is the y, so we have u prime, the derivative of x, times v plus v prime. So the v prime is the derivative of y with respect to x. Well, it's basically dy dx. So the derivative of y with respect to x is 1. 1 here is just like when you differentiate x with respect to x, we get 1. So similarly here we have 1 times dy dx, because of the different letters, times u. So this is from the product rule. From the 2y cubed, this is 6y squared times dy dx, because this is in y, we differentiate with respect to x. For the 4x to the power 5, we differentiate as usual. So 5 times 4, 20, x to the power 4, that's it. Of course, we do not use dx because that's just 1. On the right, d dx of a constant is simply 0. So after simplifying, this is just y, this is just x dy dx, and if you move the y to the right and the 20x to the power 4 to the right, we get this, and we can pull out dy dx, so we factorize dy dx, and we divide both sides by this x plus 6y squared. We get the final answer, the dy dx. This is in terms of x and y. Now plugging in, so exactly the same here, exactly the same example. We have found the dy dx, which is this. Now if you need to find the dy dx, or the gradient, when so to find the dy dx at 1, 2, so you replace the x with 1, the x with 1, the x with 1, replace the y with 2, and you get the dy dx. You can also plug in to this form here. So when you ddx both sides, you get 2, because this is from